So today we're talking about lesson 1.4. By now you know that means module 1, lesson 4. And that's important for you to know so that you can go and find your own practice that's related to what we're doing in class, okay? Today your learning goal that you've written down in your notebook is I can use what I know about exponents and place value to convert metric units. Now, let's talk a little bit about what that learning goal means. We've been learning about exponents. What is an exponent? Kish?
So you have a multiple of 10 as a base number.
So I have a base number, which we've been using 10, okay?
And there is a number in which you use to write down.
So exponents are these little numbers we write on the upper right-hand corner, and they tell you how many times you use the base number as a factor. So 10 to the power of 3 in expanded form we learned yesterday would be 10 times 10 times 10. And then its value would be 1,000. Very good. Okay, so exponents are these little tiny numbers that tell you how many times to use the base number as a factor. We've also been learning about place value, We've learned that in a place value chart, as you move left, the value gets what? Bigger. And each time, adjacent place values are how many times bigger? 10. And when you move on the place value chart to the right, the value gets smaller. Adjacent place values to the right get 10 times smaller, Very good. Today we're going to talk about how all that relates to metric units. In our measuring systems, there's different kinds of things we can measure, right? We can measure how long a distance is, can't we? Yeah. Can we measure how much time something takes?
Yeah.
Can we measure how much volume a bottle or a cup will hold?
Yeah.
Can we measure how much area how much space something takes up? Can we measure how heavy something is?
Yeah.
There's lots of different things we can measure. And in our country, in the United States of America, we use two different kinds of systems. One's called the customary system and one's called the metric system. Today we're only going to be talking about the metric system. And I'll tell you about those units in just a little bit, okay? Now, when we have 32 and 4/10 times 10, let's first write this 10 with an exponent. If 10 is my base number, how many factors of 10 are there? How many times do I have to multiply 10 to get 10? Everyone?
1.
So the exponent would be 1. So is this the same thing as 32.4 times 10? Do you agree?
Yes.
Is that the same thing as 32.4 times 10 to the first power?
Yeah.
Good. So you need to be able to change between exponents and not writing exponents, okay? Now if I'm going to multiply, is 32.4 going to get bigger or smaller? Bigger. So does that mean the decimal point needs to move to the right or to the left?
Right.
The right. How many times to the right?
1.
Because the exponent is 1, isn't it? So if the decimal point is now here, what is my answer? 324. Very good. Similarly, let's rewrite the problem, 32.4, but this time let's divide it by something using an exponent. So if my base number is 10, what is my exponent going to be? 1, because I only have to multiply 10 one time. 10 times 1, there's only one 10 to get 10. Do you agree? If I divide something by 10, is my number going to get bigger or smaller? So how does the decimal point need to move?
Left.
To the left. How many spots to the left?
1.
I can tell how many in two ways. I can either look at the number of zeros, here, or I can look at the exponent. Does the exponent always tell you how many zeros there will be?
Yes.
Interesting. So what's my answer? 32.4 divided by 10 is equal to 3.24. How do I say that in word form? Kish?
3 ones and 2,400.
Good. 3 and 2,400s. Very good. Okay, now that we've done those two together as a class, try these two on your own. First, I want you to rewrite the problem so that the second number has a power of 10. Okay, so 100 is equal to 10 to the power of 2. And I can tell because there are 2 zeros, Now, this part right here, this is the value, right? This part right here is called exponential form. I want you to draw an arrow and write that means exponential form. Whenever you have an exponent, you've written it in exponential form. I want you to know that term because maybe on the test it will ask you to write something in exponential form, and you'll have to know what that means. Okay? There's another form called expanded form, and I want you to write that in your notebook too. An expanded form means you write out the multiplication. So if 10 to the power of 2 is 100, its expanded form would be 10 times 10. Does that make sense? Okay. Over here, I have the number, the value is 10,000. The exponential form is going to be 10 to the power of 5. Let's count the zeros. 1, 2, 3, 4. It's going to be 10 to the power of 4. Do we count the 1?
No.
No. So be careful. Those of you who said 5, you're wrong. It's 10 to the power of 4. The reason why I know it's 10 to the power of 4 is because 10,000 in expanded form is 10 times 10 times 10 times 10. Do you agree?
Yeah.
So how many times did I have to multiply the 10?
4 times.
4 times. And that's why the exponent is 4. Okay? So remember, when I'm writing 10 times 10 times 10 times 10 times 10 times 10, etc., that's called expanded form. If you want to be sure you can write that on the test or understand that on the test, you'll want to take notes in your notebook. Let's write the expanded form of this number. The number is 1,000. What's the expanded form? Everyone?
10 times 10.
Is it just 10 times 10?
No, 10 times 10 times 10.
Good. How many times did I have to use 10 as a factor in the expanded form? Everyone?
3.
Therefore, the exponential form is 10 to the power of 3. Okay. Let's do it in the same order this time. My value is 1 million. Let's write out the expanded form. Everyone write it down in your notebook. Write down the expanded form. So if the expanded form of 1 million is 10 times 10 times 10 times 10 times 10 times 10, how many times did you have to multiply 10 to get to 1 million, everyone?
6.
Therefore, the exponential form of 1 million is 10 to the power of
6.
Good. What do you notice? How many zeros are there in 1 million?
6.
What's the exponent?
6.
How many times are there zeros in the expanded form?
6.
Huh. Do you notice any patterns?
No.
Interesting. I took a picture of a ruler here for you to look at. Okay, and as you know, rulers sometimes have centimeters and inches, and I took a picture of the centimeter side. And you can see that from here to here is 1 centimeter. Do you agree?
Yes.
And those little tiny marks are the millimeters. How many millimeters can we count in 1 centimeter? 10. So we know that there are 10 millimeters in 1 centimeter. Write that sentence down. Looking at the meter tape, we can see that there are 100 centimeters in 1 meter. Another way you could write that is 100 centimeters equals 1 meter. Now my question to you is, if we know that there are 10 millimeters in each centimeter and there are 100 centimeters in 1 meter, how many millimeters are there in that 1 meter? See if you can work it out in your notebook. Okay, if there's 1 centimeter, how many millimeters are there? 10. If there's 2 centimeters, how many millimeters are there? 20. If there's 3 centimeters, how many millimeters are there? 3. Wait, what?
30.
3 centimeters, how many millimeters are there? 30. What am I doing to the number of centimeters to find how many millimeters there are? Subhan? I'm adding 10. So I'm doing 1 centimeter plus 10 is 11 millimeters. How am I changing from centimeters to millimeters? How am I changing, what am I doing to this from the centimeters to change from centimeters to the millimeters? Rohan? So I'm doing 100 times 1 to get to 10 millimeters. How am I going from centimeters and changing it to the number of millimeters? What am I doing to go from here to here? Or from here to here? Or from here to here? I'm doing 100 times 10? If I take the number of centimeters I have and I multiply it by 10, that will give me the equivalent number of millimeters. Do you agree?
Yes.
So if I have, let's say, 5 centimeters, and I multiply that by 10, I will have how many millimeters?
50.
Does that mean that 50 millimeters is the same length as 5 centimeters?
Yeah.
Okay. Now if I'm trying to figure out how many millimeters there are in 1 meter, and I know there's 100 centimeters in 1 meter, what could I do? Arvind?
You can multiply 100 by 10.
I could do 100 times 10. Would that tell me the number of millimeters there are in 1 meter?
Yeah.
How could I rewrite that using exponents? How could I rewrite that using exponents? 100 times 10. We did this in our practice in our homework yesterday. Sanjana?
So for 100 times 7, using exponents, you can put it as 10 to the power of 2 multiplied by 10 to the power of 2.
Okay. I could do 10 to the power of 2 times 10 to the power of 1. Is that the same thing as 10 to the power of 3?
Yes.
And so how many millimeters are there in 1 meter, Akshay?
10 to the power of 3 equals 1,000 millimeters.
Very good, 1,000 millimeters. Go ahead and make sure you write these sentences down in your notebook. To rename meters, which is what we had in this column over here, into centimeters, you need to multiply by 10 to the power of 2, otherwise known as 100, right?
Yes.
To rename meters, all the way here on the left-hand side, as millimeters all the way over here, we had to multiply the number of meters by 10 to the power of 3, otherwise known as 1,000. To rename centimeters as millimeters, I just need to multiply by 10 to the power of, to go from centimeters to millimeters, I need to multiply by 10 to the power of
1.
Very good. We can see that when we're going the reverse from smaller units to bigger units, you'll see here centimeters are smaller than meters. When we're going from smaller units to bigger units, we need to divide. So to rename centimeters as meters, we need to divide by 10 to the power of 2. What if we're renaming millimeters over here on our chart as meters? We need to divide by what? 10 to the power of 3. Because I know that in order to rename meters as centimeters, I need to multiply by 10 to the power of 2. I can take the number of meters I have, which is 4.5, and multiply that by 10 to the power of 2 to figure out how many centimeters I have in my ribbon. Do you agree?
Yes.
So how do you do 4.5 times 10 to the power of 2? Is the number going to get bigger or smaller? Bigger. So which way do I need to move the decimal point? To the right. How many spots to the right? 1, 2. So what's my answer? Thank you. It's important to add the label centimeters. Let's think about if this makes sense or not. Because every time we solve a problem, we have to think, is my answer reasonable? If I have 4.5 meters, should I have more or less centimeters than that? More. Is 450 more than 4.5?
Yeah.
Is my answer reasonable?
Yeah.
If my answer was something like 4/10 or 45 hundredths, would that make sense?
No.
No.